Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Boeing Starliner 19th May 2022 launch. So let's dive right into it. Now before we understand this second launch, we have to understand Boeing Orbital Flight Test number 1, which happened on 19 December 2019. Now you are like, wait a minute, that's few years ago. We'll explain more about that. Now that was first try and it failed badly, meaning it was not like oops, it was like oh, god damn it. It was that bad, meaning one problem started to expose 10,000 other hidden problems. So it was really bad, meaning issues started to pop up after another. And it's like, dude, this is bad. This is not like, oops, we made this mistake. That happens. This is a normal thing. SpaceX had issue. Remember, one Dragon went boom. It happens. It's one of those things. But it was never this bad with other companies where they were like, you, this failed. And thankfully, because of this failed, we now know there are 10,000 other things. If this has succeeded, this would have destroyed the system. So it was really bad. How bad? It failed to reach orbit. Let that sink in. A company like Boeing built something that failed to reach orbit because of a clock malfunction. So that's bad. So docking with ISS, that's a no-go. On top of that, then they realized when they were analyzing the telemetry and computer controls that there was a program that's supposed to, land the stuff normal. It had a bug, and if the computer program would have executed that command specifically, it would have destroyed the capsule, because capsule can only intervene in what we call safe corridor, meaning if it's above that corridor, there is a risk it could bounce off the atmosphere. If it's below that, it will re-entry at such a shallow trajectory, it could burn up, because heat shield has an upper limit. It cannot just go YOLO at full speed. It has a maximum tolerance range. So for that reason, there is only corridor, a pathway, so to say. If you are in that pathway, you're good, everything is fine. If you are above that pathway, you can bounce off. If you are below that pathway, you can burn up. It was trying to do burn up, meaning if this puppy had run on that original software that was in there at launch time, it would have destroyed the mission. So that was really bad. So they had to do real-time patchwork instantaneously to make sure they save the craft. Now this is a landed equipment, meaning thankfully it was patch worked. They have saved the system. And after this was very embarrassing and not to mention dangerous, because people supposed to be inside there. So you cannot have a beta software in there where it's like, oops, that is not possible. Possible as in not acceptable. And during the landings, they started to do thorough inspection. Okay, let me analyze the situation. There were way too many bugs, as in lowest estimate is around 80 major bugs, meaning the system was gonna fail no matter what. So that was a very, very big egg on the face. It's one of those things that's not a acceptable scenario. You cannot have that many flaws. And not to mention, this is already behind schedule. It's not like, oh, they're running ahead of schedule, so they have cut some corners. No, it's like, dude, you're behind schedule, over budget, what the hell? So that happened on 19 December 2019. Now, after that, current system, Boeing Orbital Flight Test number 2, that happened on 19 May 2022. Now, you're like, wait a minute, that's a very long gap. Now, it's not supposed to be this long. It's supposed to be yearly. So, they tried to do this on 3 August 2021, but there was a faulty valve. And the biggest problem with that faulty valve is they did not figure out why it was faulty. Now, be mindful, this sort of thing has happened with the Dragon, where it went boom because of a faulty valve. But they figured it out very quickly. Okay, this is the problem. This is what we have to do, fix it. They dealt with NASA. It's like, hey, this is the problem, this is what we want to do, are you okay with this? We'll do some more testing, we'll double check it. Everything was like, okay, you had an issue, you solved the issue, you move forward. Here it was like, we have an issue, whose fault is it? We have no idea. Why is that? We have no idea. How can we fix it? We have no idea. They tried to change the valve, then they tried to change the whole service module, then they tried to redo everything. So it's one of those things that rework started to drag on from August to May. So that's how bad it went. So finally it was launched on 19 May 2022 at 2022 hour universal time coordinate 2022:50. Now it went to orbit thankfully this time, but the moment it reached the orbit, other problems started to crop up. Exactly like how it happened in the Mark 1 trial. Now, this time, they tried to dock with ISS, but it took much longer. And anybody who's watching the live stream would have noticed it's much longer compared to Dragon system. Now, it's like, why? What was happening there? They had some issues. And after that, NASA and Boeing, both of them are going through extensive amount of data that has been created from this mission, of course, telemetry data and all other mission parameters, to process it very thoroughly. Because it was one of those things that from outside, it's like, it's okay, it's a minor hiccup. From the inside, it's like, what the hell happened? So this happened. This is a mission. It went to orbit. It docked with ISS. It undocked with ISS. It safely landed. This has happened by the time I'm making this video. But at this point, what NASA is doing at this very date, they're working their ass off to figure out what exactly happened. So what about the report card? Like, what's the report here? It's not good. That's the reality. Long and short of it is just that it's not good. It worked, that is true, but barely, and that's not acceptable for human-rated mission. It's supposed to have people inside it. It's not acceptable. So docking ring malfunction, that's one of those things that like they popped to the docking ring. You would have always noticed, especially in the close-up cam, there is a small ring that pops out, that docks, then they call it a soft capture, then the docking ring closes, then they have a hard seal that they call hard capture, and then you have the pressurization sequence. So that malfunction, and they had to redo it again, and I think one time they reconfigured everything, retried to do it. It's like, how the heck you have malfunctioning docking ring? Then there was a glitch in the cooling system which stopped functioning. Now thankfully there was backup, but why the heck you needed the backup? There was no meteor storm, there is no EMP spike, there is no solar storm. What the hell caused that sort of issue? And there is no people inside, so you cannot have like, oh, people kind of messed up some wrong button. That happens. We are human, we make mistakes, but there was no people inside. So how the heck an automated system could mess up the cooling system? Because be mindful, if without cooling system this puppy performs, the astronaut would be cooked. So it's not what we call a non-critical system. It is a critical system. And then there were two OMEC thrusters that were also malfunctioned. At this point in time, many people are speculating that all thrusters are defective, and the only reason this mission is successful because they had three possible options. Option number A, fire the main system. It fired, it caused some red line issue, computer shuts it down. That they only get like, let's say, 10 seconds of thrust. Then they fire the backup thrusters, and it also only gives them 10 seconds of thrust. Then it also goes to red line. Third one only needs to fire for 5 seconds. It fires for 5 seconds and they have successfully completed the mission. But here's the deal, why the heck backup failed? One thing failing, that's okay, that's acceptable, that's why there was a backup, but why all three backups had to be used? So it's one of those scenarios like, dude, that means there is a systematic fault in the system, not a minor fault, a systematic fault. So that is just not good. Yes, thankfully everything that happened in the system was what we call subcritical, meaning it will annoy the crew but will not put a serious harm to their life. But again, you tried one, you almost ended it all. Try two, you almost reached a point where it's like, if any of these subcritical system fail to be corrected, you will be back to square one of death. So this is not good, flat out not good. So let's understand the cost of all this hassle, so to say. Well, Boeing is doing what we call a fixed cost contract. Now, fixed cost contract means there was barely any margin of upgrade and all that. You can do that, you can do negotiation, but generally it will be very minimal. It's like, if it's a contract of $1.2 billion, you can only ask like few million extra or something like that. And again, there are some room of negotiation, but it's not like old days where it's like, you can just keep milking it until the cows come to home. So they are working under what we call commercial crew program, that logo, and that commercial crew program is under jurisdiction of two SNC, that is NASA and Space Force. Space Force is new, NASA is the prime directive at this point in time. Now, when NASA is building a crew program, they knew for a fact that they need to do safety testing. It's not LOL, it's not satellites, it's not James Webb Telescope, it is human, which is far more pricey. So they're like, okay, we have to do two testing and two partial testing before we put full crew load on it. That's awesome, that's good, that's safe. However, it was booked for two testing. Boeing already conducted two testing. Both of them consumed money. Again, they failed both of the tests, with really bad red marks, but they failed. So what about the third test? Here's the deal. Nobody wants to pay for it. NASA does not want to pay for it. Boeing does not want to pay for it. And because Boeing is working under fixed contract, it's already causing them loss of money. And loss of money is very significant at this point here, because delay in schedule does not mean you get more money and salary starts to go up. Because again, the delay is not in weeks or months, it's in years. And I'm like genuinely worried that they might stretch it to a decade of delay. So they're losing a lot of money in this. And they are no longer, it's like, hey, NASA wants a third test, so we'll we'll forfeit the bill. They're not going to do that. So that creates an issue. And NASA is also noticing a very weird thing, that Boeing no longer has the staffing capacity which they're supposed to have for a human rated system, meaning this whole sort of craft could take upwards of 500 crew. Let's just say that 500 crew. They're only noticing there are 400 people registered for this. That simply shows a cost cutting measure. That's not acceptable. Even if this is a what we call fixed cost project, you declare bankruptcy and you let it go. You do not create an unsafe system. So that is not an acceptable. So NASA, safety directives are looking into it. It's like, dude, why do you have so few people? Red flags have been raised about that. So cost is a very serious issue. Boeing is in a lot of trouble, and so is NASA. NASA is also in a very sticky spot. And not to mention, after the landing, they realized there was way too much fume of basically corrosive agents, basically the monopropellant propellants that they were using for thrusters, that was like, then they started to say because it did not burn enough propellant, it had, you know, surplus that was fumigating. Thankfully there was no valve leak, but again, it's a issue. It's not something that you will consider GG. It's like so this is the cost side of it. Let's understand why the heck we are putting up with this. Me as in like NASA. Why the heck NASA is putting up with this? NASA have learned the hard way that they need more than one option. No matter what happens, no matter how bad or how ugly it gets, they must have more than one option. They cannot have single point of failure anymore. They have learned it the hard way through shuttle era, and they have learned it the hard way through the dependency era of Soviet capsules. So they know for a fact that human rating system must be there and must be multiples of it. So they have to have, this is their ideal dream world where you have SpaceX docked one side, Boeing docked on another side. That's their ideal world. That's what they wanted to achieve. However, Boeing is like just no. Boeing just went nope at this point in time. So you may be like, okay, what if NASA ditches them and makes a third system? For example, this puppy, Dream Chaser. Problem with that is making Dream Chaser child's play. Making it human rated, that's a bankruptcy level problem. And Dream Chaser was the very closest, you know, contender for the mission in the first place. But they were like, you know, dropped in the favor of Boeing, which at this point in time, I'm pretty sure somebody who made that decision a few years ago is like, I really made a bad decision. Now, Dream Chaser, they did not abandon this project. The company did not, Sierra Nevada did not abandon this project. They are developing this puppy behind, you know, behind closed doors, 24/7 on their own money. And due to development in private companies like Blue Origin and ULA, they are planning to make their own space station. So they need their own crew vehicle. They are trying to fulfill the bill for this puppy. So this is the closest fail-safe option we have to have a basically second human rated system. But even if NASA goes, Boeing, lol, out, I don't care, just go away. And if they pour boatload of money into this, which good luck trying to convince Congress to allocate that much of money, because again, how would you justify that we messed up this? How would you justify that? And if you justify this mess up, they will say, how about you mess up this part? So that's why like it's very difficult. And even if they somehow solve that part, it will still take few years, minimum 5, maximum 10. And that's assuming if this does not have any hidden problem. Maybe it has hidden problem the moment they start to reach it, send this puppy to orbit, then it's like, oh, it also has 10,000 problem. It could happen. So that is why NASA is so desperate to get this puppy working. They have to get this working. And all other projects are starting to being delayed because of this. Again, NASA has dockets, dockets as in like A, B, C, D, E, F, G, H, I, J. If A and B starts to take too much longer time, other projects that are you know, behind schedule as in like things that's supposed to be done, they will be delayed because again, they do not have infinite manpower. If thousands of people are just like, you know, logged into this Boeing system, it's taken away from Artemis mission. So everything else that is, you know, in the pipeline is getting delayed because of this. So it's really bad. And it's reaching a point where it's too much extra cost, too much extra time, which means it's at a risk of cancellation where somebody can just cancel the whole deal, which would be really bad. So NASA is desperate, and I mean seriously desperate, where they are like, you know what, let's just put astronaut in, because thankfully or not thankfully, this was safe, as in if they were astronaut and if they were trained and competent, they should have able to save both missions, meaning even the Mark 1 and Mark 2 literally went without a, you know, disaster, so to say. So Mark 1 they could have saved. Again, it would have been stressful, but again, astronauts are trained for that. Like that's their jam. That's like, we got this, we got this. So they could have sorted the situation. And in the second one, it was like minor issues. So they could have done that. So NASA could be desperate enough because they do not have the funding for the third test mission. So they're like, you know what, just roll the dice. Just roll the dice, put 2 astronauts, same way demo 1 and demo 2 was done. Just put 2 astronauts, let's just hope for the best. They are that desperate. So there is a need for this puppy to work. We do not want this to be cancelled unless this puppy is completely finished. And once it has orbital testing, then we can be like, you know, Boeing has to be like, oh, if we really have to, you know, deliver that, otherwise we're gonna lose money. So I mean, like, lose more money. So let's see what happens in the future. So this was my presentation on Starliner that happened recently. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.